Thank you for all coming here to me speak. My name is Seung-Joon Lee. I'm a graduate student at Gyeongbuk University in Korea. Today I'll be giving you a presentation on the result of our study. The title of my talk is Spatial Domain Analysis based on Human and Position and Movement Recognition for the Top View Imaging Systems. This project is funded by LG Electronics Home Appliance and Air Solution divisions. I will start with the introduction. Firstly, I would like to give you some background information on smart consumer electronics. As you can see in the picture, the smart home appliance industry are dramatically developing into a big part of the consumer electronic market. Many types of smart consumer electronics have been developed. Various products are using camera system for the advancing technology to recognize object position and movement for human and machine interactions. Technologies that understand the human behavior are very important these days. The goal of our study is the air conditioners. The type of air conditioners are standing type, and wall hanging types, and ceiling mounted types. Depending on the installation site, they can be divided into commercial and home. Only standing type air conditioners are equipped with voice recognition and camera systems. In many scenarios, we focused on the human recognition when the camera systems are mounted overhead using appliances such as ceiling-mounted air conditioner. Our research target are commercial spaces, such as laundromat, hallways, break room, pharmacies. In order to provide a customized environment, so each situation and space, you need a technology that recognizes spatial characteristics and pattern and control itself. In the top view scene, the image appears symmetrical around the vanishing point, such as in the omnidirectional view. The data is taken from the embedded system of ceiling air conditioner. In this paper, we propose the lightweight and efficient algorithm that can be applied to embedded system. Now we will move on to the related work. Previously, work on the human recognition is mostly based on the image taken from the side view. Recently, researchers started to work on the top view to classify human behavior. The top view is more challenging than side view to recognize human because of self-occlusion. Various methods have been proposed. The most of the detecting algorithm use constant shape picture of the human's head. Another similar method is based on the elliptical shape approximating the head contour. Other approaches use image subtraction. Moving on the proposed system. I would like to elaborate on the general architecture of the models. We propose the model for the human detection consisting of several steps. Firstly, in order to make the salience map from the acquired image, using the combined results of the intensity feature and image subtractions. The intensity features are useful for detection static object. The subtraction feature is used for the detection object motions. Then we extracted candidate areas for the classification from the salience map. Secondly, we use transform the extracted image candidate by calculation the rotation matrix around the center This method is suitable for detecting rotated and scaled images. These results are used for human recognition using the classification algorithm. In the next step, the heat map is generated by accumulating the detection result. Finally, we clustered and analyzed the heat map to derive the activity level and recognize the spatial domains. Intensity picture can be obtained in the following steps. Input is provided in grayscale image format. 9 spatial scales are created using Gaussian pyramid from the input images. Each picture is computed as a center surrounding difference operation similar to the visual acceptance field. Center surrounding difference operation are differences between a fine scale and coarse scale with the point-by-point subtractions. A consecutivity map is combined with picture by a crossing scale combination which consists of rescale of each picture to scale 4 with point-by-point addition. We cannot make a buffer with limited embedded resource, so we created one background image and used a basic running method for the fast subtraction operation. Background images creation and subtraction have parallel structures. Creating subtraction operation use specific T0 and Tn frame image to make the foreground image mask M. It is used as the mask for the Tn+1 frame images. This is a current background images. The current background images and the previous background image P are applied to update the background image B. The background image is generated with the following learning equations. The scalar eta is learning rate. We use set 0.02. A consecutivity map is created by subtraction the background from the Tn+1 frame images. The intensity consecutivity map and the subtraction consecutivity map are added into the salience map. Each combination weight varies depending on the scenarios. When all pictures map are combined into salience map, the prominent objects may show strong activity peak. Numerous locations are shown in picture C. Candidate region must be extracted from the many strong intensity responses. The candidate image areas are extracted from the saliency. The top view image appears as symmetrical. Therefore, naturally aligned images can be obtained through appropriate rotation transform from the center coordinate. The center coordinate denoted the center of the image and vanishing point. The converted images are shown more naturally with the head at top and leg at the bottom. Candidate images are used for classifications. The classifications learning model need to have an image patch. The human body patch is modeled with Hawk descriptor. The feature vectors are constructed using Hawk with 8x8 cells. We use the linear SVM algorithm to train the human classification models. Before training picture vector, we resize the patch to a fixed size 48 by 96 resolution to increase the processing speed. The image patches are consisted of 30 people with 10 pictures per person for each class. Data was acquired in different environments with various illuminations and posture and so on. Then the human classification model predicts whether the candidate image patches are human or not. Experiments. We are using embedded system where the camera is installed on the ceiling point straight down at the scene. The data are taken from various heights and places. The acquired images are grayscale images. Full size is 640 by 408 pixels. Let's move on to look at the data represented on the table. The main purpose of proposed algorithm is reduce the region of interest. Table A shows how the region of interest affect performance. The first item displays the size of the region of interest, and the second item represents the performance. When we reduce the region of interest, the performance is 40 times faster than searching the entire region. This is the result of the hallways and pharmacy scenes. The spatial domain analysis results are visualized in the activity level heat map. The visualization operation is not executed in the real system. As you can see from the heat map, you can see where the people are staying. I will show you a video clip. This is the result of the brick room. Data was obtained at height 2800 millimeter. There are bending machine at the top of the image, and there are water purifier is in the upper right corner. High activity level can be observed around the water purifier. This is the result of hallways. Data was obtained at height 2900 millimeter. People move up and down in the images. The active and inactive areas are divided to the left and right. This is the result of the pharmacies. Data was obtained at height 2700 millimeters. This area is divided into two sections by the counter. The upper part is guest area, and the lower part is the pharmacist area. The guest area only shows activity near the counter. And there is activity in all of the pharmacist's areas. Conclusions. In this paper, we propose the method for the human recognition algorithm for smart consumer electronic using the embedded systems. We make the saliency map for the detecting a static object and motion object. An intensity algorithm similar to visual receptive field in use. We implemented a lightweight subtraction image algorithm with the background running. We have reduced the region of interest by extracting candidate area from the saliency. Lastly, we analyzed the spatial domain through human movement recognition. We verified these results through the experiment that the results show real-time achievable speed. Further work. There are many resource limitations in the embedded systems. We will need some more optimized algorithm for the application. We aim that device will be able to estimate where they are installed by themselves through the spatial domain analysis. Yeah.